Good evening, students. So today became late, little late, right? 5-10 minutes late, we are starting the class. All right. In the last class, I told you that there was one question we did. One car starts with an acceleration of alpha, goes and attain maximum speed, then goes for retardation and then stops. What is its maximum speed and how much distance it has traveled? Something like that. Check the last question we discussed. Am I correct?
Yes, sir.
And I told you that there is a simpler method than what we did on the other day. So simpler method, same question. Okay, car starts from rest, has an acceleration alpha, attains maximum speed, then you apply the brakes, finally it stops. Okay, so same question, but this time we are going to do with the graphical method. And this is smaller method than what we did. Okay, see how. So in a graphical method, I'm going to make a graph between velocity and time. Why velocity and time? Because its area gives me displacement. And I want to find displacement. That's why. So first to start with, it says that the car starts from rest. The car starts from rest means you'll start from here. That means origin. Then it says it moves with a constant acceleration alpha. Acceleration is alpha. Acceleration is the slope of VT curve. Okay, you already have studied that. Acceleration is slope of velocity time curve. And slope means what? Tan theta. Okay, so how will be the graph? Graph will be like this. A straight line. Whenever slope is constant, the graph will be straight line. Okay, done. Then it goes and attain maximum speed. You're saying this is only the maximum speed. This is Vmax. After that, what? And after that, you are applying brake. And then coming to rest. So then retardation you are applying. Is the retardation constant? So yes, that also is constant. So that means again slope constant. So that's it. That's the graph. This is for acceleration. This is for retardation. Okay. Now what we can do? Let's assume this is some angle. Let's say theta. And this is phi. Right? Then make them as two triangles. One shows retardation, one shows acceleration. Okay. Then retardation and acceleration happens for some time. Let's say this is T1 and retardation for T2. And see in the question, it was given to us that the total time taken is T. And that means T1 plus T2 is T. Equation number 1. Now you see, what is given? Alpha is the acceleration. Acceleration is alpha. Acceleration here means slope. Slope means tan theta. The tan theta is given to you as alpha. This is tan theta. And in this triangle, if you see tan theta, it is actually height by base. What is height? Vmax. And base is what? T1. So I can write Vmax by T1 equal to alpha. Exactly same way. Tan phi value is given to us as beta. And what is tan phi? Again, height by base. That is Vmax by T2. From here, T1 value I am going to get. What is T1? T1 is V maximum by alpha. And from here, T2, V maximum by beta. Now what? After finding T1 and T2, I'm going to put this in this equation. T1 plus T2 equal to T. Let's put T1 value V maximum by alpha, T2 value V maximum by beta equal to T. Okay, solve it. Take LCM. The LCM is alpha beta. Okay, then here will be V maximum into beta, and here is V maximum into alpha. So V maximum into beta plus V maximum into alpha equal to T. V maximum you take common, V maximum is common, and alpha plus beta, and take denominator that side, that's alpha beta T. So V maximum I got. What is V maximum value? V maximum value is alpha beta T by alpha plus beta. Okay, this is V maximum. Then I have to find distance also. Now distance means its area. What is its area? Half base into height. So half base into height will be writing half base is T1, height is V max. Here half T2 into V max. Its area. Add both. The total distance is, when you are adding, V maximum by 2 is common. So V maximum by 2 into T1 plus T2. Right? V maximum is what? You already found. Put it there. Alpha beta T by alpha plus beta. So 2 into alpha plus beta. And T1 plus T2 is T. So T square. That's all. Over. Okay.
Yes.
So this is simpler method. This all I did because I had to explain you. But if you know that I won't be writing all this. Tan theta equal to alpha, tan phi equal to beta. Directly I'll be writing alpha equal to V max by T. So T1 equal to this. Beta equal to V max by T2. So T2 equal to this, and directly I'll put and get the answer. Okay, so note that one. This is graphical method. Completed?
Yes.
Okay. One more question we'll solve so that we have an idea how to construct the graph. Okay. So let's see how the question is. Question is, a Diwali rocket. Okay. A Diwali rocket starts from rest with an acceleration of 5 meters per second square. Acceleration of 5 meter per second square. Okay, then up to how much time it can go up? For a few seconds it will go up, right? After that, what will happen? It will blow somewhere and then it will return back. That's how we have seen Diwali rocket. Okay, so we say its fuel finished in 5 seconds. Okay, then what? It continues its journey upwards, and then returns back. Okay, then what we have to find? Question number 1. Find the maximum height to which rocket moves. Okay. Second, total time taken by rocket in entire journey. Okay, something like this. 2 questions are there. So note these questions and then we'll discuss how to solve it through graphical method. Completed?
Yes, sir.
Okay.
Yes, sir.
Okay. Now I'm going to make the graph, just see. Which graph first of all? Graph, we will always construct VT. Always. Because in VT graph, we get slope also, that means acceleration also, and its area gives us displacement also. So first graph that we need to make while solving the question is VT graph. Okay. So let's make it. This is VT. This is V and this is T. According to the question, rocket starts from rest. Rest means initial velocity is 0. Okay, so it will start from here, from origin. Okay, point number 1. Second thing is, he says for 5 seconds, it was moving with acceleration of 5 meter per second square. That means constant acceleration was there for 5 seconds. So constant acceleration, that means constant slope, that means straight line. Okay, so for first 5 seconds, it's like this. 5 seconds. Okay, remember that. That's 5 seconds. Okay, that we'll make it later. Then what happened? Fuel is finished. So fuel has finished. In these 5 seconds, it must have got some velocity, obviously, because acceleration is there. Velocity keeps on increasing. Where velocity is increasing? Upward. Okay. Suddenly fuel is finished, but velocity is not zero. So because of that, what will happen? It will continue to move upwards. Okay. It's like you are moving in a car. Okay. Accelerating the car. Suddenly, car's fuel is finished. So will car stop at that moment itself? No, because car has got velocity. It will go to certain distance before coming to rest. Exactly same thing is happening with this rocket also. Okay, so this will move up, but what is happening when it's moving up? Its velocity is decreasing. Okay, as it's moving up, its velocity started decreasing. Why? Because now it is under gravity moving and gravity is pulling it downwards. Okay, so it will reach to its highest point. At highest point, its velocity will become 0. So how will be the graph now? Its velocity has to become 0. So graph will be like this. Negative acceleration. Like in the previous question we did. Alpha was positive acceleration, so like this. Beta was retardation, so like this. So here this is retardation. What is the retardation? G, acceleration due to gravity. Okay, so this is the point which represents maximum height. Here velocity has become 0. Then what will happen? It will turn down and then it will go downwards. Okay, but what will be the acceleration? Downward, G. And velocity will become negative because it's coming downwards. If upward velocity is positive, downward velocity is negative. So we'll continue this on. Why? Because here also value of acceleration was G. Here also value of acceleration is G. But this side, velocity is downwards, acceleration also downwards. So it's acceleration. Whereas here it was retardation. Okay, this is the graph. That's it. Graph is over. Now we have to get the values. First of all, tell me, did you understand the graph? Acceleration, retardation of G, okay, then downward journey, acceleration of G. Is this clear? Yes, students?
Yes, sir.
Everybody understood? This is retardation. And this again is acceleration. When is acceleration? When is retardation? When velocity and acceleration are in opposite direction. Okay, then it becomes retardation. When velocity and acceleration are in same direction, then it becomes acceleration. So when there is a downward journey, velocity is also downward and G always acts downwards. So it's acceleration. When it's upward journey, this represents upward journey. Velocity is upward, velocity is positive. But acceleration is G, downwards. So it's a retardation. That's why the graph is like this. But you see, velocity is above 0. So that means velocity is positive. Here, velocity is negative. That means it's downward. Okay, so this is the graph. Now, let's solve. So let's put certain values which are given to us. Is given to us that this here is 5 seconds. Okay, this, let's say theta. Right, so 10 theta value also given to us. What is 10 theta value? Acceleration value. How much it is? 5 meters per second square. What this represents? This represents V maximum. Okay, this also you keep. This is, let's say this is alpha. This is also alpha. Same angle. Why same angle, you know? Because here also acceleration value is G, here also acceleration value is G. Though one is positive, other one is negative, but still value is same. Okay. So 10 theta is 5. So here you see what I can write. We can write V maximum by T. What is T? 5. equal to 5 meter per second square. So V maximum is what? 25 meter per second. So that means after 5 seconds, what is the V maximum value? 25 meter per second. Okay. When fuel finished, speed of the rocket is 25 meter per second. Okay. Further, is it going to move up? I said yes, it will move further up. How much further it can move? I know. U square by 2g. Okay. So maximum height. The height a rocket will travel. After 5 seconds. After t equal to 5. Now, at t equal to 5 seconds, speed is 25. So height it will travel is v square by 2g. That means 25 into 25 by 20. This is 5, this is 4. 125 by 4. Is this the maximum height? Yes, this is maximum height. But how much it is from ground, I don't know. From the height where the rocket is after 5 seconds. From there, it is 125 by 4. But at t equal to 5 seconds, where is rocket? I can easily find area of this. Area of this only gives us the value of the displacement. So area of this is what? So half base into height. What is height? Vmax. Vmax is 25. This is 125 by 2. So at t equal to 5 seconds, where it is? 125 by 2. And after t equal to 5 seconds, further goes 125 by 4. So what is maximum height? Maximum height is 125 by 2 plus 125 by 4. What is going to come? 375 by 4. Okay, when you solve this one, you get 375 by 4. Take LCM and get it. 4 is the LCM. Okay, 2 2s are 4. 2 into 125 is 250. And here, 125. So 250 plus 125 is 375. And this is maximum height. First question's answer we got. Tell me, is it clear to you?
Yes, sir.
Okay, note this one. Half of the question is done. Now remaining half you have to do. Completed?
Yes, sir.
Okay, guys. So now we have to find time. Okay, so this all I am removing. The work is over. 375 by 4 we'll remember, because in return journey also it has to travel the same distance. Okay, so you remember that. We'll require it. Now, time. This is 5 seconds. First, I have to find this time. And then only I'll be coming to this. So this time, can I find? I have the answer. Yes, we can find. How? I know the slope of this. That means 10 alpha value I know. How? Because it's upward journey. Okay, it's upward journey. It's under gravity. After the fuel stopped, it is under gravity. So 10 alpha value is G. I know. Okay. 10 alpha according to this graph will be something like V max. And if I say this is T2, then T2 equal to G means 10. Okay, and V maximum value I know it's 25. So 25 by 10 equal to T2. So I have the T2 value, 2.5 seconds. T2 value we have. Okay, note this. Done?
Yes.
Okay, see now. Now we are going to talk about this downward journey. This represents downward journey. Let's make a triangle here also. This is the triangle. And this is the time we are trying to find, T3. Okay. Now what I know about this journey? Again, this is alpha. I know this because this is also under gravity. So 10 alpha value we already have. This is only 10 alpha. 10 alpha. But in this diagram, 10 alpha is G only, no doubt about that. It's G. But here, this value, which is let's say V1, I do not know. Because this alpha belongs to this triangle. So I'll write, find 10 alpha equal to V1 by T3. Height is V1, base is T3. I have written. Okay. 10 alpha value is G, we know. So G equal to V1 by T3. This is equation number 1. One information. Another information I have is the distance traveled is 375 by 4. Upward it went, the total distance, the maximum height, it went up to 375 by 4. Now when it is going to strike the ground back, it has to travel the same distance. Okay, so it means I have the distance. In return journey, distance traveled is 375 by 4. Now I know one more thing. Area of this gives me distance. Area of this triangle will be 375 by 4. Okay, so what is area? Area is half base into height. Now what is base? T3 and height is V1. This is equal to 375 by 4. But unfortunately, neither I know V1 nor I know T3. But one relation I know. What is that? G equal to V1 by T3. So V1 equal to what? GT3. That means 10 T3. I'll put in this one. See then. 1 by 2 T3 into V1 value from here. GT3. GT3 means what? 10 T3. I'll put it here. 10 T3 equal to 375 by 4. 2 5 ja. And with 5 I can 5 7 ja, 5 5 ja, I think. Yes. So I got T3 square is equal to 75 by 4. So T3 equal to 5 root 3 by 2 seconds. 5 root 3 by 2 seconds. So this is 5 root 3 by 2. Total time he was asking. We got everything. 5 root 3 by 2 plus 2.5 plus 5. So total time is 5 plus 2.5 plus 5 root 3 by 2. 5 root 3 by 2 will be how much? 8.5 by 2. So 4.25 approximately. Okay. This is our answer. 11.75. Did you understand?
Yes.
So this all we did with the graph. There was no equation of kinematics used anywhere. If you use equation of kinematics, it will be longer quiz. Okay, note this one. Completed?
Yes, sir.
Okay.
Yes, sir.
Now, one more thing I'll tell you in this. Sometimes they won't ask you to find anything. Okay, they will just tell you to make the graph. Okay, rocket is there, rocket is projected, this much acceleration, all this. They'll say you make VT graph. So this is VT graph. Okay, then they can ask you to make ST graph of this. How to make that we'll see. They will not say you to find anything, okay? Just make the graph. So ST graph, if they are asking, how to make ST graph out of this, that we have to learn. Okay, we already know, we studied graph already. Now we have to again use what we learned. So see then, first is this motion. What motion is this? This is the accelerated motion. Okay, that is acceleration. Starting from 0. So starting from 0 means here also it will start from 0. Here. Okay. Now displacement graph you are making with t. So if we go back to equation of kinematics, then it is actually S equal to ut plus half a t square. Quadratic equation is there. So it is a parabola. Remember that. So I'm going to make a parabola for positive acceleration. Okay, for first part. Then this part, this is retardation. Retardation also parabola only. Okay, how will be that retardation part? The retardation part. Like that. Okay, slope is changing then. Change in velocity is decreasing. Okay, so that's why it's like this. Then what is happening finally in this one? It is coming back to the ground. Its displacement is becoming 0. So that means here you have gone to this much height. This represents maximum height actually. Okay, what is this? This is maximum height. Now what to happen? You have to come back on the ground. You have to come back to the ground. Again a parabola only. Okay, again a parabola. Okay, this has become a little sharp. You can make it like this way because the space is not there. Okay, or let me make it slightly smaller. So first one with the yellow pen, then second one, the orange, like this, and then the blue. Okay, this one is what? This one is acceleration. Retardation. Downward acceleration. Okay, they can say you to make this graph alone without any values and this graph without any value. They are not asking anything to find, just make the graph. Did you understand that?
Yes, sir.
So how to make the graph is very, very important. Okay, everyone understood?
Yes, sir.
Yes, sir.
Okay, great. Note it. Done?
Yes, sir.
Okay. Put now the next heading as relative motion. Relative motion. What is relative motion? Relative motion means comparison of motion of two objects with each other. We are going to compare the displacement of two objects. We are going to compare the velocity of two objects. We are going to compare the acceleration of two objects while in motion. It is called relative motion. Okay. Comparing motion variables of one object. No, comparing motion variables of two objects. Two objects with each other. With each other. Okay. Now assume. Okay. Assume that this is origin here. From this origin, an object A is somewhere here. An object B somewhere here. Okay, position of object A is XA and position of object B is XB. Okay, so if I ask you how far is B from A, what you will tell me? How far is B from A? How far is B from O is XB. Yeah. How far is A from O is XA. Okay. A's position from O is how far A is from O, XA. How far is B from O, XB. But now I'm asking how far is B from A? That means I'm asking you this. What do you write? XB minus XA. This is XB minus XA. And this I'm calling as position of B with respect to A. Okay, how far is B from A? I'm writing as position of B with respect to A. That means what is the position of B from A? Okay, we write it as position of B with respect to A. You told me it is XB minus XA. Perfect. How to write this? We write it as XBA. It means XB minus XA. Position of B with respect to A. And it is vector. So since it's one-dimensional motion, it doesn't make much of the difference to us. But when we go into two-dimensional motion, it will make. So let's go with the vector only. Okay. Position of B with respect to A is equal to XB minus XA. If I ask you position of A with respect to B, position of A with respect to B, then this is
XA minus
because
XB.
it's negative. Okay, so it will become XA minus XB. XA minus XB. It's negative, it's less. So it will come negative. Okay, so this is regarding position. How to write? Position of A with respect to B. This is position of B with respect to A. What is this? Position of A with respect to B. A with respect to B. Okay, note this. Completed.
Yes, sir.
Okay.
Yes, sir.
Right. So position of B with respect to A, I know that is XBA is XB minus XA. Now, if I want to find velocity of B with respect to A, velocity of B with respect to A, what I have to do? I know that if position I know and I find the derivative of that with respect to time, it becomes velocity. That means velocity of B with respect to A is actually d by dt of position with respect to A. If that is so, then this will become d by dt of xb minus d by dt of xa. Means this is Vb and this is Va. So velocity of B with respect to A is this. What is the meaning? Meaning is very simple, you know. Suppose you are going in a car. This is your car. This is the A. This A car is moving with 8 meters per second. Right? Another car is there, which is overtaking you, maybe B. There is a car B. Okay, there is a car B over here, which is overtaking you, and its speed is 12 meters per second. So I am asking you, how faster is car B as compared to A? How much faster is car B as compared to A? Tell me.
4 meters per second.
4 meters per second. That means velocity of B minus velocity of A. That is only velocity of B with respect to A. Okay. How much faster is B as compared to A? As compared to A. That is only VB minus B. Okay, that's what we are studying. That is the meaning. Same way, how much slower is A as compared to B? So 4 meters per second. But if I ask how much faster is A compared to B, assign minus 4. We'll find that VA minus VB is minus 4. Okay, so VBA, velocity of B with respect to A, means how much faster is B as compared to A. Did you understand that?
Yes.
Okay, note
Yes,
that.
sir.
Completed?
Yes, sir.
Yes, sir.
Okay. Now acceleration. Acceleration of B with respect to A. Again, same thing. Acceleration is what? Derivative of velocity. So d by dt, or rather first acceleration of B with respect to A. That is actually d by dt of velocity of B with respect to A. So what is going to come? It will come out to be acceleration of B minus acceleration of A. And we write it as acceleration of B with respect to A. And in other ways, what it is? How much more is acceleration of B with respect to A? From A, okay? How much more is acceleration of B compared to A? That is the meaning. Okay, note this one. Then I'll ask you, what is the need of this? Why are we studying this relative motion? We already have done everything. Graph we have studied, equation of kinematics we have studied, speed, velocity, everything we have discussed. So if everything is over, what is the need of this relative motion? We can solve every question in kinematics right now. Then why this? Done?
Yes, sir.
Okay.
Sir, I have a doubt, sir.
Ask.
Sir, in this question, like in previous question, we have did dot product, sir. Why not cross product? Since
Where?
velocity is
In
vector.
which one?
Sir, like in previous question, velocity of B with respect to A, we did as a dot product, sir. Why not cross product? Because velocity is a vector quantity, no, sir.
We didn't do with any dot product or cross product here. It is a single quantity we are writing. No. This is when I say XBA, that is position of B with respect to A. This is one thing only. There is no product here.
No, sir. Like we did as d by dt dot d x bar A by dt. Like in that question, sir.
Okay. See, when I am writing d by dt of xb with respect to, that's what you are asking. Am I correct?
Yes, sir.
So it means it is d by dt of xb minus xa. Right?
Okay, sir.
There is no dot product, beta. D by dt of xb, then x.
Okay, so it's off and it's not dot product.
No, there is no dot.
Oh, okay, sir. I just understood it wrong. Okay, sir.
Okay.
Okay, so thank you, sir.
Yeah. Clear, students? Everything fine?
Yes, sir.
Okay. Right. So I was asking you, what is the need of this relative motion? We can solve all the
Sir, in
questions.
the first class you said no, sir. Rest and motion are relative terms. So, like how objects move with respect to different reference frame. For that, we are using a relative motion.
Yeah,
sir.
point. This is to understand in a more better way. We are having this also. True. But actually, we are studying it to make our calculation easy. Okay, it's not necessary, not at all necessary to study it over here to solve 1D motion. Okay, but why are we studying? It makes our problem solving a lot smaller and a lot easier. Okay, that's why we are studying relative motion. How it is going to make it easy? Let's see. Okay, one by one, we will start doing it. But first, equation of kinematics for relative motion. It changes. Okay, so I'm writing it. Equation of kinematics for relative motion. So we have mainly 3 equations. Okay, so I'm writing one by one. First equation, v equal to u plus at. So we'll be writing v of a with respect to b. Here I'm writing a with respect to b. Okay, or you write b with respect to it, doesn't make any difference. Okay, so VAB is equal to UAB plus acceleration of A with respect to B into T. Everything became relative, nothing else. It's all the same thing, but it became relative. Second equation, displacement of A with respect to B equal to UAB into T plus half acceleration of A with respect to B into T square. Okay, third equation. Velocity of A with respect to B square equal to velocity, initial velocity of A with respect to B square plus 2 acceleration of A with respect to B dot, here dot is there, acceleration into displacement of A with respect to. Here dot is there. Okay. Three equations. Is this clear, students?
Yes, sir.
Yes, sir.
So we have to use them. Whenever we are trying to use relative motion, we will be using them. Now you can ask me why dot products are here. Reason is because this is square. This is square. V square, U square. two vectors, same vectors, their product. You can find that only when there is a dot product. If it is a cross product, it will become 0. You all have studied vectors, right?
Yes, sir.
See, if I say you vector A cross vector A, what is the answer? 0. Why 0? Because angle between them is 0. A cross product, when we say A bar cross B bar, it is basically AB sine theta into n cap. What is this theta? Theta is angle between two vectors. Theta is angle between two vectors. Angle between two vectors. Okay, so if both vectors are same vectors, then angle between them is what? 0. And sine 0 is 0. Right? So we cannot have cross product. This is also a dot product actually. VAB dot VAB. That's how it came V square. This is also UAB dot UAB. So U square. So this is also a dot product. This is also a dot product. So that's why this also has to be a dot product. Why? So that you can get scalar quantity. This is a scalar quantity. This is a scalar quantity. So this also needs to be scalar. Then only you can add. A vector cannot be added into a scalar quantity. A vector can be added into a vector quantity only. Scalar can be added with a scalar quantity. So this is scalar, so this also needs to be a scalar. That's why there is a dot product. Is it clear?
Yes, sir.
Good. Note this one, then one by one we will see how to apply. Okay? Completed?
Yes.
Okay. So we'll start with the simple questions. Very, very simple questions. The first question is, okay. There is a car A. This is your car A. Okay, and here is car B. Okay, car A is moving with, let's say, 12 meters per second. And this is moving with 8 meters per second. Right. This is 20 meters. Okay, distance between them is 20 meters. Acceleration is not there. Constant speed motion. Okay, both cars have constant velocity. Okay, so simplest of question. Question number 1. Find velocity of car A with respect to B, with respect to car B. Question number 1. Question number 2. find time when car A will overtake car B. These are two questions. Okay, note that. Noted?
Yes.
Okay. You are going to give me the first question's answer.
4 meter per second.
4 meter per second. Velocity of A with respect to B, that is VAB. VA minus VB. 12 minus 8. 4 meter per second. Perfect. Question number 2. Find time when car A will overtake B. We can see that car A is faster. It will overtake, that we know. We can understand that. But in how much time? Okay, now see now what I'm going to do. I have already velocity of A with respect to B. Okay, now if I ask, how much ahead is car B from A? Hmm?
20 meter per
20 meter. So how much more car A has to travel to overtake car B?
more than 20 meter.
20 meters, because when it will overtake 20 meters, it has to cover 20 meters distance, right? So
Yes.
position of A with respect to B. Okay. Sorry, position of B with respect to A, no? Yeah. Position of B with respect to A. Oh, okay. Position of B with respect to A is 20 meters. B is 20 meters ahead of B, ahead of A. That's it. Work is over. Now what? Now we have to see that how much more A has to travel as compared to B. This XBA is there, 20. But how much more A has to travel? 20 meters. So I'll be writing like this. XBA that means the displacement of A with respect to B. Write it that way only, otherwise you will get confused. Displacement of A with respect to B to catch the B or to overtake the B. Okay, to overtake B is 20 meters. Okay, and this is equal to displacement of A with respect to B to overtake it. Remember that, the word overtake. Okay, that's equal to velocity of A with respect to B into time, because displacement is velocity into time only when acceleration is not there. Or you can use first equation of kinematics also, rather second equation of kinematics, S equal to ut plus half at square. When A is not there, what we will do? S equal to at only, or rather ut only. Okay, S equal to ut plus half at square. When acceleration is 0, what you'll write? S equal to ut. Exactly same thing I'm going to write. Displacement of A with respect to B is 20 meter. That is equal to velocity into time. So 20 here. Velocity of A with respect to B already calculated. Where it is? This. So 20 equal to 4 into t. That means what is time? 5 seconds. That's your answer. In 5 seconds, our car A will be equal to car B. You can individually also we can see. Its speed is what? 8. In 5 seconds, how much this will travel? Say 40 meters more. So somewhere here it will be, let's say. How much it travels? 40 meters. In same 5 seconds, how much this will travel? 12 into 5, 60. That means from here to here. Yes, both are at the same level. So this is about to overtake this. But how I found? I found in very, very easy way with a relative motion. Okay. So displacement of A with respect. Now here, which displacement you are calculating? How much A has to travel more as compared to B. Okay. That we return. Equal to velocity of A with respect to B into time. That's all. I got the time immediately without doing anything. When I'll know it, I can directly see what is the gap between them. 20. Okay, fine. What is the gap between their velocities? 4. That's it. 20 by 4 is my answer. That fast. Understood that?
Yes.
Okay, note
Yes,
that.
sir.
Yeah, note it. Completed?
Yes, sir.
Yes.
Okay.
Yes,
One
sir.
more easy question. Any doubts? Okay.
No, sir.
Okay. Let's go for the next. Now this time, both the cars will be coming towards each other. This is one car, car A, and another car is over here. Okay, this car B. Let's say gap between them is 100 meter. This is coming with 10 meter per second. This is coming with 15 meter per second. In this direction. This is in this direction. Okay, now what I want. Directly I want find when two cars will meet. Find when two cars will meet. Okay. What we have to do? Okay, one more thing I'll tell you. Okay, fine. It will be easy for you to understand that. See, I'll try to tell you. Whenever I say velocity of A with respect to B, see it in this way. Okay, you calculated VA minus VB and you got its value. Okay, try to understand it in this way that we are making here, when I say velocity of A with respect to B, that means I am saying now B is at rest. Okay, what I am saying? B is at rest. And that means this is at rest. This will not move because you said with respect to B. So B is at rest. This is going to come towards that one with velocity of A with respect to B. Its velocity will become VAB, and this is at rest. Try to solve in this way. Okay, it will make it a lot easier for you. Previous question also. Okay, see now here. Now, first thing is we have to find VA minus VB. So VA is 10. Minus VB is 15, but 15 is in opposite direction. So what shall I do? Minus 15.
Minus of minus 15.
So minus and minus plus. So 10 plus 15 is 25. So now B is at rest and this car is coming with VAB, that is 25 meters per second. So what it has to do? This car has to go and meet this car. That's what the question is. When two cars will meet. This car has to go and meet this. So how much distance it has to travel? 100 with what speed? 25. Answer is 4 seconds. Understood that?
Yes, sir.
This is how you need to take relative thing. Okay. So now, or otherwise also no problem. X, A, B we have to find. So how much A has to travel to meet B? XA minus XB. It's 100 meters. The gap between the two is 100 meters. Same formula. XAB equal to VAB into time. So 100 equal to 25 into T. T equal to 4 seconds. Okay, this is the way we should be calculating. But remember that it will help you whenever you say that velocity of A with respect to B means take this as at rest. So its velocity is VAB. Now, how much distance is there? 100 meters. Its velocity is 25. Directly you can calculate. That is kind of a shortcut for you so that you can calculate it faster. Okay, note this one. Completed?
Yes.
Okay. Now, let's go one step higher. One step higher means let's have acceleration also. Okay. See, like we'll frame one question. Here is a car which is at rest. Okay, at rest. And there is a boy. There is a distance between them. There is distance D. Or taxi, this is okay. There's a taxi. Okay, what happens? As soon as boy saw taxi, taxi starts. Taxi starts moving with acceleration A. That means he saw that taxi starts. And immediately at the same instant, he starts running because he wants to catch the taxi. Okay. At the same instant, boy starts running with maximum speed u. With maximum speed u. Okay. Okay, fine. What should be this speed so that he can catch the taxi? So that he can catch the taxi. So see, all the questions that we have done so far in this relative motion, no? It is always about two bodies and it is always about meeting, catching, overtaking, meeting. So that is a clue for you. Whenever two objects have to meet, overtake, okay, or catch, then you have to use relative motion. Okay, it makes the problem easy for you. Not problem easy, problem solving easy for you. Okay, note this one. Noted it?
Yes, sir.
Okay. So this is slightly upgraded question than what we have done so far. Why? Because in this one, acceleration is there. So see them. How to solve? This is his boy, B, and this is taxi. Okay. So now, very clear it is. A boy wants to catch the taxi. How much more it has to travel? Distance d. Okay. So distance to be traveled by a boy with respect to taxi is d. How much more distance will be traveled by a boy with respect to taxi is d. I'm right. Okay. Velocity of the boy is u, initial velocity. And velocity of the car is 0 because it says it starts moving with acceleration a, whereas boy starts running with maximum speed u. So boy speed is u, whereas its speed is 0. So I'm writing initial velocity of boy with respect to taxi. What it will be? Ub minus ut, we know, but ub is u and ut is 0. So it's u. Okay. How much distance more boy has to travel with respect to taxi? D. Initial velocity of boy with respect to taxi, u. Okay. Acceleration of boy with respect to taxi is AB minus AT. But boy is running with maximum speed only. There is acceleration, constant speed that too. Okay. So boy doesn't have any acceleration. So 0. But taxi has acceleration a. Okay, no problem. Minus a. So ultimately, minus. Done. We have written everything. What we are finding? Time. So one equation which connects x, u, a, and t is our second equation of kinematics. What is that? X, b, a, equal to UVA into T plus half acceleration BA into T square. No issues. Let's put the values. D equal to UT minus, why minus? Because this is minus half A T square. From here we can get the time. But is he asking time from us? He didn't ask time. Question is not asking time. Okay. So yes, this equation we can use to find time, but the question is not asking time. So no problem. Then what? I'll be going for third equation. Third equation we'll go for. Okay. First you note this one. If time we would have asked, we would have done this. And quadratic equation we would have solved and we would have got the time. Okay, note this one first. Done that?
Yes, sir.
Okay. So if he would have asked time, we would have solved it, we would have got the answer. But he didn't ask. He said that what should be this speed so that he can catch the taxi. Now, one important question I'll ask you. If suppose speed of taxi become more than boy speed, can he ever catch the taxi? If speed of the taxi become more than the speed of this boy, which is coming from behind running, can he ever catch the taxi? No. If its speed became more than you, then he can never catch it. So that means the maximum time he has got is by the time its velocity and its velocity are equal. Before that, he needs to catch it. Otherwise, not possible for him. Okay? It is not possible for him to catch the taxi. At that point, we have to write, then only we'll come to the answer. Okay? So I'm writing it, just see. I'm just removing this question from here. Okay. So I'm writing, boy can catch the taxi till speed of taxi is less or equal to speed of boy. Once it becomes more, no chance. No chance. So that means final velocity of boy with respect to taxi, maximum, we can say is can become to 0. Less or equal to 0 we can write, but I'm putting it as 0 right now. Velocity of boy with respect to t is 0. Okay, maximum. If it's more than that, forget about catching. So velocity of b with respect to t is why this is required for me. This is required because he didn't ask time. If time was there, we would have done this. But without time, he is asking. So then we have to go for the third equation. And for third equation, you require final velocity. So that's why final velocity we are writing. Okay. So velocity of boy at the most with respect to taxi can be 0. Now I'll apply third equation. What is third equation for me? Velocity of b with respect to t square. Initial velocity of boy with respect to t square plus 2 into acceleration of b with respect to t into x with respect boy with respect to t. This is t, right? Not a. Okay, let's put the values. And this I am removing from here because this is not required. Let's put VBT is what? 0. UBT is UBT is u square plus 2. Acceleration of BT minus a. XBT is d. So bring it here. This is minus u square equal to minus 2ad. So the speed with which he should run to catch should be equal to root 2ad. Then only he can catch the taxi. Otherwise, not possible. That's what he's asking, no? What should be the speed of the boy so that he can catch the taxi? It should be equal to root over 2ad. Did you understand?
Yes, sir.
Students, everybody understood, no?
Yes, sir.
If time he was asking, we would have solved with the second equation. There was no problem in it. We would have got the answer. Okay. What should be the time in which he should be catching the taxi? But he didn't ask. He asked us what is the speed with which he should run so that he can catch the taxi. So what is the clue? Clue is this. Boy can catch the taxi till speed of taxi is less or equal to speed of the taxi, speed of the boy. Okay, so when it becomes equal to the speed of the boy, then velocity of boy with respect to taxi becomes 0. And with that, we solved third equation of kinematics and we got u equal to root over 2ad. Okay, now this one. In day after tomorrow's class, we'll finish 1D motion and we are going to start your 2D motion, projectile. Okay.
Yes, sir.
Yes, sir.
Maybe 3 or 4 questions more we'll do on relative motion and we'll be going on to projectile motion in our next class. So 1D motion is over. So I'll be taking test very soon. We'll decide it in the next class when we should have the test on this. Okay. One worksheet I gave you. Have you completed all the questions in that? Motion under gravity?
Sir, not yet completed that worksheet, sir.
Okay. So in the next class, that also we'll be discussing. Okay. Relative motion also one worksheet I'll give you. But I think better it is after next class I'll give you once it's completed. Okay. So next class, first motion under gravity, doubts, relative motion problems that I have to discuss with you, and then we'll start projectile motion. Okay. So is it over?
Yes, sir.
Okay then.
Yes.
Yes.
Okay then. See you on Thursday. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.